So that's somebody's fault that I'm not I'm gonna rename nameless. Okay. So the first one that's on there has m times m to the fifth. And if we want to simplify that and leave it in terms of powers, remember yesterday I showed you that you could write it out if you wanted to, that m 5 times, and then count how many m's you have total? Or what was the quick shortcut way that you could use? I could do it like this, where I have m from the first one, and then 1, 2, 3, 4, 5 of them to give a grand total of how many? 6. But what's the shortcut method? What could I have done instead of writing them all out and then counting? I just add these exponents right here, right? If there's no number listed, it's understood to be a 1. And I just take 1 plus 5 would equal 6. So that's kind of the shortcut way, is if I could just add the exponents. When you're multiplying like bases, you add the exponents. So like on the one right below that, it has 4x squared times 2x to the third. And so you're supposed to then simplify that. When you do this one, when there's numbers involved in the front, we multiply the numbers together. So what's 2 times 4? 8. And then when it comes to the letters, we simply add the exponents. So if I have 2 in the front and 3 in the back, how many do I have total? 5. X to the fifth. So that's one of the properties that we talked about yesterday. For those of you who were gone, that's one of the properties. Is everybody okay with that? Those of you who were here yesterday, does that make sense? Okay. Then, another property that we had, when we do the next one over, we had negative 2c to the third squared. And if we wanted to, we could write it out 2 times and then multiply everything together, and that's kind of the long way. Or we could do the shortcut method, which is one of the power products. It is power to a product, because there's multiplying going on the inside. And if you remember what we did yesterday, we talked about it being the distributive property, meaning we give to everybody, right? So that means I take the squared to the negative 2, and I take it to the 3. And what you do is you end up taking negative 2 to the second, and then on the c, you have c to the third to the second. You multiply the exponents. You're not adding this time. So first of all, what I need to know from you guys is, does anybody know what negative 2 squared is? What's negative 2 times negative 2? Careful. Negative times a negative would be a positive 4. Good. And if I had c to the third, but now I'm squaring it, that means that I would have c to the third and c to the third again. So how many would I have total? If I have 3 and 3, how many does that make? 6. So instead of me writing it out twice and counting, I could just do 3 times 2 here to make it go faster, right? And just have 6. On the next one, it has negative 6 squared. And what they want you to do for that one is you're taking negative 6 times negative 6, which we just talked about the signs. If you have a negative times a negative, what do you get? You get a positive, right? Yeah. A negative times a negative? And then 6 times 6 would be 36. But now the catch is the next one. And I'll put it in red so that you see the difference. And I'm really glad that they put this one on the review, or on the notes. Because this is probably the biggest thing what people get wrong. Is the negative 6 in parentheses?
No.
No. On the first one that we did, it was saying negative 6 times negative 6. On this one, you do exponents before you do the negative sign. So really what this is saying is negative 1 times 6 squared. That's really what that says. If the negative sign is not in parentheses, it's saying that you do the squared first, and then you multiply it by negative 1. So what's 6 squared? What's 6 times 6?
36.
36. And what's 36 times negative 1? Negative 36. Good. So I want you to see what the difference is and the similarity is. They look the same almost. If it's in parentheses, though, it's saying negative 6 times negative 6. And if it's not in parentheses, it's saying 6 squared first and then the negative sign. So be careful. Lots of times we get that wrong because of that. Okay? What do you think of that? Everybody okay? Okay, again, for this type of problem, we got to distribute those exponents through. So first of all, this is going to here. Now that negative sign is in parentheses, so it's really me saying negative x times negative x times negative x times negative x, which would mean I have an even number of negative signs. Is an even number of negative signs going to be positive or negative?
Negative.
Careful.
Positive.
If I have a negative times a negative, I'd get a what?
Positive.
And if I have another negative and a negative, I'd get a positive.
Yeah.
And a positive times a positive would be a positive.
Positive.
Yeah. So this would be positive x to the fourth. Then I distribute here. Everybody know what 3 to the third is?
9.
Not 9.
Oh.
Remember, it's 3 times 3 times 3. How much? 27. Because 3 times 3 is 9, and 9 times 3 would be 27. And if you couldn't remember, use your calculator, right? Then, x squared to the third. Our quick little rule, remember, we're multiplying the exponents. So what do I get? X to the sixth. Nice work. And the last one, wise guy to the third. Then, to simplify, combine like terms. Is there any like letters in there? Uh-huh. If I have x to the fourth here and x to the sixth there, how many x's do I have? If I have 4 in the front and 6 in the back, how many do I have total? 10. So 27, x to the 10th, y to the third. Okay, when you're multiplying, again, like terms, add the exponents. X to the second times x to the third would be what? If I have 3 in the front, or how much? Not quite. I have 2 in the front, 3 in the back, for a grand total of 5. For the y's, I have 6 in the front, 5 in the back. How many would I have total? 11. And that would be my answer. Okay? So as far as that goes, that's what we did yesterday. That's what we talked about. When you have like letters, you add exponents when you're multiplying. If it's power to a product, like that one was right here, distribute this to each piece. Then you combine like terms. Okay? That's what we talked about yesterday. So for those of you who were gone yesterday, that's what you missed. Okay? That's what we had. All right? So what do you guys think? Okay, so right now, what I'm gonna do is then I'll leave you